Hey, welcome back. Today we're going to pull back the curtain on a little piece of network magic called inter-VLAN routing. It's this awesome, invisible process that keeps all the different parts of a network safe and organized, but it also lets them talk to each other when they need to. It's a real balancing act. But that brings up a really good question, right? It sounds kind of backward. I mean, why would you go through all the trouble of building these digital walls inside your network, only to immediately start figuring out how to poke holes in them? Well, understanding the answer to that is the key to this whole thing. Okay, so before we start connecting these separate networks, we really have to get why we separate them in the first place. Just picture a big company office, right? You've got finance, you've got sales, and you've got engineering. Now, for security, for plain old organization, you do not want everyone having access to everything. You definitely want finance's servers kept separate from whatever engineering is testing. That idea, that separation, that's the core of it all. Now, in the networking world, we create these departments using something called a VLAN, a virtual local area network. And that word virtual is everything here. See, even though everyone might be plugged into the exact same physical switch, we use software to draw these invisible lines that split it into totally isolated networks. So sales stays in the sales VLAN, finance stays in theirs, and neither one can see the other. And just like that, we've created our big problem. By default, PC1 over there in the sales VLAN has absolutely no way of communicating with PC2 in the finance VLAN. None. They're on the same piece of hardware, but from a virtual standpoint, they might as well be in different buildings on opposite sides of town. So the big question becomes, how do we let them talk, selectively, without just tearing down all the walls we just put up? Well, the very first solution was, let's just say it was direct. It was the most brute force, straightforward approach you could possibly imagine, and hey, it worked, but as you're about to see, it was pretty clumsy. The approach was dead simple. Just use a router. A device whose entire job is connecting different networks. So you'd run one physical cable from the switch to the router just for VLAN 10. And then you'd run a second physical cable for VLAN 20. The router then acts as the middleman, passing traffic between those two connections. Simple enough, but not exactly elegant, is it? Yeah, you can probably spot the massive flaw here right away. What happens when you have, 5 VLANs? 10? What about 50? Routers only have a handful of physical ports. You would run out of spots to plug things in almost immediately. This method just doesn't scale for any network of a reasonable size. It's a cool piece of history, but thankfully, things got better. So that physical limitation, running out of ports, it forced engineers to come up with a much smarter solution. They developed this really fantastic workaround, and honestly, it's got a great name, Router on a Stick. So instead of all those separate cables, Router on a Stick uses just one single special connection called a trunk. Think of it like a multi-lane superhighway packed inside a single cable. All the traffic from every single VLAN travels down this one highway together. But here's the clever part. Every little piece of data is tagged with a label that says which VLAN it belongs to. It's just so much more efficient. But wait, how does the router handle this big jumble of traffic all coming over one single wire? Well, the magic is all in the software. What the router does is it creates multiple virtual interfaces. They're called subinterfaces on its one physical port. It's like it creates a virtual doorway for VLAN 10 and another virtual doorway for VLAN 20, and on and on. It's a brilliant virtual trick to solve a physical problem. And here's just a little peek at the configuration that actually makes this happen. Don't worry, we're not going to go through the commands line by line, but this shows you that it's all just a software setup. It's an engineer telling the router, hey, on this one physical port, I want you to create a virtual path for VLAN 10 and another one for VLAN 20. It really is a powerful and elegant hack. But, even that clever hack has its limits. For the really big, really high-speed networks, we needed another huge leap forward. And that brings us to the modern standard, which is basically getting rid of the external router completely. And look at that, the stick is totally gone. The modern way uses a much more powerful device called a layer 3 switch. In networking, layer 3 is just a fancy term for the layer where routing happens, making the smart decisions about where data needs to go. So what we have here is a switch that can also think like a router. All that communication between VLANs now happens right inside this one box and at incredible speeds. This device is a true hybrid. It's got two jobs. On one hand, it does all the regular switch stuff, keeping local traffic flowing super fast within each VLAN. But it also has the brains of a router built in, so it can make those smart decisions to direct traffic between the VLANs. It's seriously the best of both worlds, all packed into one very efficient piece of hardware. And oh man, the performance boost is just huge. Because the traffic never has to leave the box to get routed, it's just drastically faster. That lower delay, or what we call latency, that's the difference between a perfectly clear video call and one that's all choppy and frustrating. With no external links to slow things down, it's the scalable, high-speed standard you'll find in pretty much any modern organization. So let's just take a step back for a second and look at the journey we've just been on. We went from a really clunky physical solution all the way to this highly efficient, integrated, and almost purely virtual one. The evolution becomes so clear when you see them all side by side like this. The old legacy method, that's really just a history lesson now. Router on a stick, that was a super clever fix, and it still works great for smaller setups. But for any network that needs serious speed and has to be able to grow, the Layer 3 switch is really the only way to go. It's just faster, it's more efficient, and it's built for what we need today. And at the end of the day, all three of these methods, from the oldest and clunkiest to the newest and fastest, they were all invented to solve that one core problem we talked about at the very beginning. They're all just different ways of reaching the same goal, letting our separate virtual networks talk to each other in a controlled, smart, and efficient way. You know, this whole journey from a clunky physical problem to a sleek virtual solution, that's a story that you see again and again all over the world of technology. It really makes you wonder what other elegant, completely invisible systems like this are humming away right now just beneath the surface, making our entire connected world actually run.